Hey, what's up guys? Welcome back to another video in the Kotlin series. In this video, I'll be teaching about data types. Alright everybody, welcome back. So now we know how to create variables. So now I'm going to show you the different data types that you can store within those variables. So in this episode, we'll be taking a look at the basic data types, which are known as primitive data types within languages. So every language is going to have a set of primitive data types, and they're usually the same ones, in every language. So that's going to be like numbers, characters, booleans, and stuff like that. And then you have other more complex data types like strings, but that's not technically a primitive, so I'll be making a whole separate video on that, okay? Same for arrays, that's a different type of data type, so I'll make a separate video on that as well. So this website here is actually a great resource for the different data types. It gives you a really nice table for each of them. So you can see exactly how much space they take on your computer, what the number range is, and all that fun stuff. So I'll leave a link for this in the description below. And this is also the official Kotlin documentation, so you can definitely trust it as well. Now, if you want to represent a whole number and store a whole number in your program, you can do that using the integer types. So there's 4 different types of integer types. This is byte, short, int, which is short for integer actually, and then long. So each of these different types have different number ranges. And so you may want to choose a different one depending on the size of the number that you want to store. So for example, a byte is 8 bits, and I'll explain what that means a little bit more in a second, but you can see that the minimum value is -128 and the max value is 127. So you can store a very small number range within a byte. And then for a short, you can store slightly larger numbers, so -32,000 up to positive 32,000. So yeah, a little bit bigger. But then for the int data type, it stores roughly -2 billion to positive 2 billion. So this is a much larger number range. So for the most part, it'll store any number that you would want to store in a program, just generally speaking. But of course, if you need larger numbers, you can rely on the long data type, which stores a very big number. I don't even know how to say that number, but it's going to be -2 to the 63rd power to positive 2 to the 63rd power minus 1. So as you can see, it's a very large number range. So the question you may ask is, why would I want to choose one data type over another besides the fact that they store different number ranges? Why not just go with a long every time for every single variable so that I can know that I can store any number or any number of reasonable length? And the reason is going to be memory. So each of these has a number of bits or a size. So the byte is 8 bits, the short is 16 bits, the integer is 32 bits, and the long is 64 bits. So it multiplies by 2 every time. And you may have heard of binary before. Binary is just zeros and ones, and that's the language that your computer speaks on the lowest level, just zeros and ones. And there's plenty of videos if you want to learn more about, binary and bits and all that fun stuff. But all you have to know is that whenever you create these variables, what will happen is, let's say that you make a new byte variable within your program, right? What this will do is allocate 8 bits of space in your computer's memory and your RAM so that it can store the value of that variable in that space, okay? So if you store a long, for example, it's going to allocate 64 bits of space in your computer's memory. And that's actually not that big, but the more longs you have, the more it's going to add up, right? And also you have to worry about systems that have limited resources. So, nowadays your computer is going to be able to handle whatever you want to do in your basic programs, right? Like, it's not really concerned which types of variables that you use for the most part, because computers nowadays are very powerful. They have a lot of resources. But even nowadays, there are smaller devices like IoT devices or embedded devices that rely on smaller resources, so you have to be aware of the amount of memory that these variables are using, okay? So generally speaking, with all that said, for your everyday programs, it doesn't actually matter too much which ones that you use, but there are 4 different integer types for a reason. That's why we have the byte, the short, the int, and the long, so that you can store different number ranges, but also with different memory allocation amounts as well. For the most part, you're going to use the int, and this is just the most common data type. It's also the default data type for numbers, and I'll explain more about that in the next episode where I teach you guys about type inference. But yeah, those are the integer types, which are for whole numbers, okay? Now let's move on to the floating point types. So there's only 2 floating point types, and they also differ in the amount of size that they take up in your computer's memory. So this one's 32 bits, and this one's 64 bits. So a floating point type is simply a decimal number, right? So for example, if you have 3.14 for the number pi, then that's going to be a floating point number because it has a decimal in it. So since the double here is 64 bits and the float here is 32 bits, the double is the one that can store larger numbers, or more importantly, you could have more precise numbers. So that means that you could have more zeros after the decimal. So you could do like 0.000000001. So I'll give you guys some examples of floats and doubles in a minute, but just know that they are floating point types, meaning that they are decimal numbers, and the double stores 64 bits, meaning that it is more precise because it can have more decimal digits. So those are the numbered data types that you're going to be using most of the time, but you also have these special unsigned integer types, which are just whole numbers that cannot be negative. So we still have a byte, a short, a int, and a long, but instead of just byte, it's a u byte, meaning that it's an unsigned byte, a u short, a u int, and a u long. And they still maintain the same size, so 8, 16, 32, and 64 bits. But what differs is that they cannot be negative, right? So this means that they can store a higher range of positive numbers, which makes sense because those numbers that could previously be negative can no longer be negative so that you can store higher numbers in the positive direction. So instead of negative 128 to positive 127 for a byte, you can now store 0 to positive 255. And then you have 0 to 65,000, 0 to 4 billion, 0 to 18 bazillion, whatever that number is, okay? So 2 to the 64 minus 1, so it's a much larger number in that case. So if you're ever developing a program that does not rely on negative numbers, you get the benefit of higher positive numbers, which is really cool. So those are the basic number data types. Now let's jump into some other data types. So here's a Boolean, and a Boolean is actually a very simple data type. It stores only two values, true or false. So whenever you create a Boolean, it can only be true or false. Technically, they could also store null, but it has to be a nullable type. So don't worry about that. We'll talk more about that in the future, okay? So the last data type I'll be teaching you about is the character data type. So far we've seen a little bit about strings. Strings can hold like my name or just a sentence or something like that. But a string is made up of characters, so individual symbols that compile into one thing, okay? So in this case, a single character would be just a single symbol. Like, for example, we have 1, it can be A, it can be B, it can be C, it can be ampersand, it can be any symbol on your keyboard. It can also be these special characters here, so to represent a tab, to represent a backspace, a new line, a carriage return, a single quotation mark, a double quotation mark, you get the idea. You can also have what you call Unicode characters, which is a whole other set of special characters that you can use, and I'll show you a little bit about that in the future, okay? So that's just an overview of the basic primitive data types within Kotlin. So you have numbers, which includes integer types, and then you have floating point types, and then you have unsigned integer types, and then you have booleans, and then you have characters. Now let's go ahead and jump back into the code so we can see how we can use those data types in our programs. But we're going to start with whole numbers, which we saw were called integer types. So we can do var age int is equal to, we could say 22. So we've just created a new variable with the data type of int, which stands for integer. And this stores a range of about -2 billion to +2 billion. And if you don't remember the range, you can simply look up that website I showed you just now. But yeah, so we can store a big number here if you want to. So at a certain point, it gives you an error because you've gone too far. The IDE is smart enough to know what the range of an integer is, which is very cool. So for example, we've gone too far here, so it says the integer literal does not conform to the expected type integer. So if we were to just change the integer type here to a long type, this would be valid because longs store much larger numbers. So this is valid now, as you can see. We can print this out if we want to. So just as a reminder to run this, you can go here, click the play button, and then click run. And there we go, we get 22, whatever that number is. It's a very large number, but we can see that it printed out and there were no errors, so everything's working perfectly. But if we want to work with smaller numbers, we can use something like a byte or a short. So we can do byte, and we could do something like maybe 222, but that's not allowed, right? Because a byte that's signed is -127 to +128, or maybe -128 to +127. I think that's probably right there. So that's not in the range, right? So we have to change this, either the value itself or the type, so we can make it a short instead. So now that's perfectly valid, okay? So again, the main reason you have these different data types for different ranges of numbers is because each of those different types take up different amounts of memory in your computer. So if you know you're going to be using smaller numbers, or let's say you know you're going to need to use less memory because you have a computer that has less memory, then you may want to use something like a byte or a short because they use less memory, right? So that's more memory efficient, because if you have a lot of variables that stores a lot of numbers and you're limited on resources in terms of memory, you want to use a short or a byte or just something that makes sense for whatever you're working with, okay? It really depends on the situation, but I just wanted to give you an idea of why you have these options to choose from. But nowadays, you're probably just going to use an integer or long for the most part, just because we have really powerful computers now that have lots of abundant memory, and that's not really an issue unless you're working on something specific like a smaller device or something like that, okay? So let's go and check out floating point numbers or decimal numbers. So if we want to store something that has a decimal number, we could do something like a weight, for example. So var weight, and then we can give it a type for one of the floating point types. So we can do double, equal sign, and then give it a weight. So we can do 150.2. So now if we go ahead and print this out just to see what it looks like, if it works and everything like that. We can see that it prints out 150.2. There we go. So within Kotlin, you have two floating point types. You have the double and the float type. And the double is going to be the larger one, which is 64 bits. You're probably going to see the double more commonly, even though it's the bigger one. That's also the default one that is used if you don't specify the type, which we'll learn about a little bit more in the future. But if you want to use the float type, you could do var weight2, for example, give it a type of float, and then give it a value of, let's say, 100 or 270.0. So now we have created a new variable called weight2 with a type of float and given an initial value of 270.0, but it's complaining because floating point numbers have to end with a f. So either a lowercase f or uppercase f. And this is required within programming languages, not all of them, but some of them, so that you can distinguish between a double and a float. Because like I said, because by default, if you don't specify with the f, it's going to be a double. It's going to be assumed to be a double. So this f here simply tells the compiler that you're working with a float, not a double. Even though we specified it as a float and we specified the type of the variable here, we still need to give it the f on the end so that we can tell it that the value that we're putting into the variable is a float, not a double, and it should be treated that way, okay? So that's just something you have to do for floats, but for doubles, you don't have to put anything on it on the end of it. But yeah, we can play around with this more if we want to, so we can make weight, even more precise. And what that means is that, double has a very large range. You could use a lot of decimals, so you could do 0.0000002, and that's perfectly valid. So this is more precise because it goes, deeper, I guess. I don't know what you would call that, but it's got a higher number place in that direction, so it's much more precise. So that's just one reason you may want to use a double instead of a float. Float is less precise because it allows less amounts of digits in that direction, so you could use less precision. So it's another situation where it's a trade-off, depending on what you're trying to do. But for the basic programs that we're going to be making, most of the time we're just going to be using a double. We don't have to worry about using a float, but it's nice to know that you can use the float if you need to. Now I'm going to show you guys the Boolean. So the Boolean is a very simple data type, like I told you. So we can do var is hungry, and we could say Boolean, and a Boolean can only be true or false. So we can do false, there we go, or true. So if we print this out, is hungry, we should get true. There we go. So we know that that variable stores the value true, and it's a Boolean. All right, so the next one I want to show you is the character. So a character, like I said before, is just really a symbol. So we could do var symbol char, which stands for a character, is equal to, and then use single quotes. So instead of double quotes for strings that we were working with before, for a character you have to use single quotes, and then within those single quotes you can put a symbol. So D, that's a perfectly valid symbol, or 1, or 2, or 3. You can't do more than one because it's only one single character. So then if we print that out, we should get 1 into the console. And I just want to illustrate something. So if we have var number 1 int is equal to 1, these are not the same thing because this is storing an integer and this one's storing a character. They may look similar and they may look the same when you print them out, but behind the scenes they're different. Like I said, we're not going to go into detail on how to do strings, but strings are really just a sequence of characters. So if we're going to do var name again, string is equal to Cody. I already had this before, but a string is made up of a sequence of characters. So since a single character is just one symbol, a string has a bunch of symbols in it, as you can see here. So behind the scenes, this is made up of these symbols here. So all these characters are essentially compiled into one single data type string. All right, so the last one I want to show you is the unsigned whole numbers that we looked at a little bit a second ago. So unsigned whole numbers are the same thing as the whole numbers that we saw up here, the byte, the short, the integer, and the long. The only difference is that they are unsigned, meaning that they only go in the positive direction, so you have more range in that direction. You can't do negative numbers, so all of that capability is moved over to the positive side. So instead of having, for example, negative 128 to positive 127, you have 0 to positive 255, I believe. So let's go ahead and try that out. So we could do var, what's this one called? Age. We'll say age2. And then instead of a short, we can do an unsigned short. So we can do u short. That's how you do an unsigned data type. So var age is a u short or an unsigned short. And that's going to be equal to, let's say 200. Make it age2, by the way. There we go. And very similar to the float where we have to put an F on the end of the float to mark it as an actual float, we have to do the same thing for unsigned numbers because by default they're going to be treated as signed numbers. So to make it unsigned, we just put a U on the end. So you can do uppercase or lowercase u, and that makes it an unsigned number. we can store it into this variable here, okay? So now if we print this out, we should get 200. There we go. So there's something very interesting is if you do a long, a long is already a very big number, right? But since we are now making it an unsigned number, it's going to be a much larger range in the positive direction. So we can store a very large number within this. So let's put the u on the end and see how far we can go until it turns red. Holy crap. There we go. So we found the breaking point. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 different digits that we can do for a unsigned long. Pretty amazing. So that illustrates that it's a much larger number than just a regular long because it's unsigned, okay? Alright, so those are all the basic data types within Kotlin. They're also known as primitive data types. Now you know when you're making your programs what types of data you can store. You know what your options are now. And then in the future, I'll show you guys how to work with these different variable types. But for now, just know that you have all these options here, and it really depends on the situation and context of which ones you want to choose for, like, you know, if you want to use a unsigned whole number or a signed whole number, and which type, so short, byte, integer, long. It really depends on the context, okay? But that's it. Thanks for watching, everybody. See you in the next episode. Alright, so that's it for this video. Thanks for watching. In the description below, I'll leave a link to the code for this episode so you can check it out. You can bookmark it, come back to it later. If you forget any concepts or you just want to review the concepts I taught in this video, I'll mark everything up with comments so you can come back and read the code without having to rewatch the video, although your reviews are greatly appreciated. So yeah, I'll leave a link for that in the description below, so make sure to check it out. And another thing is I'll leave a link to our Discord server. It's a big community for programmers. You can ask for help on your programming projects if you're stuck on something, or maybe you can get some new friends. If you don't have any friends, there's lots of people here. It's growing really fast. You can find lots of people who are passionate about the same things as you. For example, if you like Minecraft Spigot development, you can find lots of people who like that. If you like C++, if you like Java, if you like web development, it's a really, really big programming community. So feel free to join. There's a link for that in the description below. And the last thing I want to tell you is that if you want to support this channel, you can click the join button below this video, and you can join this channel as a member for as low as 99 cents a month, and you can cancel at any time. You get some cool perks like early access to all of my new videos, a cool rank on my Discord server like you see right here on the side, YouTube members, and also you get to see yourself on the screen like you see right now. So if that sounds cool to you, feel free to join. If you don't want to, that's fine. If you can't, that's okay too. I really just appreciate you watching the video anyway. And thank you. Thanks a lot. And that's it. So if you like this video, leave a like. If you want to see more, subscribe. And peace.